Was actually an outbreak in Asia of SARS several years ago. I believe I just checked. It was like 2002. There was a SARS outbreak, and SARS is like, think of it like the cousin of COVID. It's a respiratory disease. SARS stands for severe acute respiratory syndrome. And so after that outbreak was controlled, it was confined to Asia, and then it was managed. It didn't become a global pandemic like COVID. Researchers started to study the virus that caused SARS years back, and they started to try to develop a vaccine for it. So when COVID came out, right, and this causes global pandemic, there's this new virus. They already had a lot of research that had gone into the SARS vaccine, and COVID is a SARS virus. So it's not like they were starting from scratch. They had all of these years worth of vaccine or research into this virus and vaccinations for SARS. And so they applied that to COVID. So they weren't starting like just from scratch. Also, another thing to consider is that this is a global pandemic. It's affecting people all around the world. So you're getting top scientists from all around the world collaborating on coming up with an effective vaccine. So they're sharing all their knowledge, resources. So you have a lot of experts working on this together rather than just one country focusing on this vaccine because it's affecting the population or just a couple of labs. Like we're talking, it's a global like effort. Number three, a lot of people in an effort to get this pandemic under control, right? Because really, our best hopes of getting back to normal are either the vaccines are effective and so people don't get sick from COVID anymore, and we see fewer and fewer and fewer transmission rates. Or two, we develop a really effective treatment that if somebody does get COVID, they can be treated like right off the bat. We can give them this medication and they can get better. And right now, what we have are the vaccines available. And so, really, this is our best chance right now at controlling and reining in the pandemic. So, you have a lot of people investing financially in the production of the vaccine. So, there's a lot of money being pumped into research and trials and vaccine production. And so that's also helped to accelerate the rate at which this vaccine has been put out. Of course, there are still some long-term effects that we don't know, not just to the vaccine, but to COVID itself. We don't know what's going to happen to people that recovered from a COVID infection. What are the long-term implications of the virus itself? Could we have long-term lung damage? We know that there's research that shows that even in asymptomatic people, they have heart damage. And so the long-term effects of the virus are unknown. The long-term effects of the vaccine are unknown because we don't it's been a year. It's been less than a year. I mean, it's been months since the vaccine's been out. So really, there's no way of guaranteeing either way what the long-term implications are going to be. So people really have to decide for themselves which is the lesser of two evils, to take their chances becoming infected with COVID and having complications with it, or to go ahead and get the vaccine and then have the potential of having side effects with the vaccine. So really, at some point, we're all going to have to make that decision, or get sick or get the vaccine, and then ultimately it'll be up to you. But there's definitely hesitation. Parents are concerned about other vaccines perhaps causing autism. You guys watched a documentary on Thursday called Calling the Shots. And so I use this to take your attendance. So for those of you that are keeping up with your work, kudos to y'all. But I see 9 of y'all that haven't. I'm going to enter this on Skyward tomorrow. So if you haven't watched the documentary, I really encourage y'all to watch it because it addresses the autism concerns that some parents have with vaccines. And so there's enough research that a lot of different studies that have disputed that vaccines are directly linked to autism, but vaccines can make some children sick. So if you watch the documentary, they really do a good job, I think, looking at both, the positives of vaccines, but also the negatives of vaccines. And so in this documentary, there was a little boy who was vaccinated as a child for polio, and they caught polio from the virus, from the vaccine. So the vaccine that was supposed to protect them made them sick. Now, can this happen with the COVID vaccine? No. And we'll look at why. But some vaccines can give the person the infection that they're trying to fight off. If it reactivates, that could happen in some cases with some vaccines. And so the little kid caught polio. In another one, a little kid got vaccinated and they got really sick. Like they got a real rare sort of neurological disease. I think they started having seizures, and now they have neurological problems that they didn't have before the vaccine. So the vaccine was directly linked to their illness. And that was because they just happened to have a particular genetic composition that made them sick. So there are all these risks, right, that could happen, and people are concerned. But we also know that there have been diseases, or there are diseases that have been eliminated through vaccination efforts. And so one of the benefits of vaccines is we can become immune to these deadly illnesses. We can eliminate them from the population. And so just to give, I know we looked at, I think, Ebola a little bit last time. Not Ebola. Yeah, we looked at Ebola, but I want to show you smallpox because smallpox was a very common infection hundreds of years ago that people would develop. It was very contagious. This little girl has smallpox. She's covered in these pox all throughout her body, and it has a 30% mortality rate. So just to give you the comparison, I know we talked about the COVID mortality rate, and it depends on your age and things like that. But for most people, it'll be maybe like a 3% mortality rate. So 3 out of 100 people will die. Smallpox would kill 30% of the people that caught it. So that would be like 30 out of 100. So our class size, just to give you like a reference, there are 27 of us in here. So out of the 27 of us, what's 27 divided by 3? I can't do mental math right now. Just to give you an example.
It's 9.
9? Thank you. So 9 of us would have died from smallpox in this class. Like, that's pretty significant. I mean, just any death for many of these preventable diseases is one death too many. And so if we take a look at, okay, so coming back to the PowerPoint, smallpox, you don't even have to worry about this disease anymore with this 30% mortality rate because of vaccines. And so everybody was required to get vaccinated against smallpox until the last known case of it was in the late 1970s, early 1980s. And that's it. So no one else on the planet can catch smallpox because this virus has been eliminated from the human population. Like, how cool is that? And that was possible because of vaccines. By the way, if you survived it, you were immune, you had immunity, but 65 to 80%, I have the statistics here, 65 to 80% of survivors were disfigured from it because they would have scars from the pox on their body. So you can imagine the emotional distress and just, I mean, it was a nasty virus, but you would have immunity if you survived it, but it had a very high mortality rate. But fortunately, due to vaccines, you don't even have to worry about this anymore. So vaccines have the potential of eliminating diseases like in first world, or like in the United States, we don't have to worry about polio. We don't have to worry about, for the most part, sometimes you'll have measles outbreaks in unvaccinated populations. And I think they mentioned that in the documentary. Some people will choose not to vaccinate based on religious reasons or personal reasons. And sometimes you'll see outbreaks in those communities of non-vaccinated individuals. So here's chickenpox. And most of you have probably not had chickenpox because it's one of those vaccines that is now like a required childhood vaccine. If you had chickenpox, you would break out in these little pox, and you'd get super itchy from head to toe. You would have a fever. You feel miserable. I know because I went through it. And then you want to scratch so bad, but if you scratch at those little sores, you get a scar from it. So they're like, don't scratch, don't scratch. And so I, of course, like I was so itchy and I was a kid, like I would scratch or pick at it. And I know I have a scar somewhere here on my forehead and I think on my arm or leg somewhere. And so it was just like, it was typical childhood disease though. A lot of kids would get it, but now I have lifelong immunity from it. If you've never had the chicken pox, then chances are you've been vaccinated, so you can't get it. Even if you come into contact with it at the mall or at a restaurant, because of your vaccine, you will now be immune to it. And so the thing about viruses is, even if you survive it, you can have issues from that viral infection years down the road. So I caught chickenpox when I was like 7. I haven't, like, that was years ago. But because I had chickenpox, I am now at risk of developing shingles. So those of us that have had the actual virus, the virus becomes incorporated into our DNA for life. And even though now we're immune, like I can't get chickenpox again, or if I ever do, it's super mild, like it's not as bad as the first time. But now I'm susceptible to shingles. And so that is a long-term effect of the virus. Same thing with HPV. HPV is a virus that causes genital warts. And it is known that if the genital warts are not going to kill you, but what can happen is the virus can cause cervical cancer in women. So virus can cause cancer or trigger cancers. Virus can cause illnesses down the line. And so that is the thing with COVID, is even though if you survive it, because the mortality rate's not all that high, and some people will use that as one of the reasons that we should open up. Not, it's like survivable, 97% of people survive, and that's true, but we don't know what the long-term complications of COVID infections are. Like, we don't know years down the road, like what effects it could have on the lungs or what effects it could have on the heart. And so the best thing, I mean, if you can prevent it, is to, I would think, weigh your options. Do I want to take my chances or do I not? And so It'll be up to you to decide, um, weigh the pros and cons. But whenever we get sick from an infection and our immune system has to work to fight it, we develop active immunity. And so through active immunity, because our immune system is triggered and we have to go through the immune cascade and response, we create lifelong cells called antibodies that are going to respond to the infection and remember the infection. And your immunity can last. So to be immune means that you can no longer get sick from that virus, for months, for years, or for life. So different antibodies will last you a different amount of time. For example, have you guys heard of tetanus? I don't know what pictures I'm going to find, so viewer discretion is advised. Tetanus is a bacterial infection that you can develop from, like a bacteria that can be found in soil. And so you may have heard of, well, if you step on a rusty nail, that you can get tetanus if you're not vaccinated. And the reason that rusty nails are associated with tetanus is the rust is not going to give you that, but a rusty nail's probably been sitting out for a while. So it's coated with bacteria. And so tetanus, and let me look, hopefully I don't find anything too graphic. Of course it's graphic. Okay. So with tetanus is also called lockjaw, because what tetanus does is once you get this bacteria into your body, it produces a toxin that causes your muscles to contract, and they stay contracted and stiffened. And so it's called lockjaw because your jaw will lock, like you cannot move the muscles anymore, and they become very tight. You can't open your mouth. We use muscles to breathe. So if those muscles become locked and paralyzed, we can't even take a breath. So tetanus is deadly. Every single one of you should be vaccinated against tetanus because this causes death. And so this one here is one of the recommended childhood vaccines that you will get. Like, you cannot come to public school unless you have the tetanus vaccine, unless you have the whooping cough vaccine, unless you have the chickenpox, polio vaccines. These are recommended and required vaccines that you have to get to go to public school, because public school is like a cesspool of disease, because you have a lot of people together. Little kids are like coughing all over the place. You don't wipe their nose or go like this and then touch the desk and share candies, whatever. So schools are high places of, places where the infections are very typical. So if you're going to go to public school, you have to be vaccinated against a lot of these, communicable diseases. And so tetanus is one of them. And so the thing with tetanus is you have to get a booster every 10 years because your antibodies wane. And so you start to lose those antibodies after 10 years. You have to get a booster recommended every 10 years to prevent, you from getting tetanus. So some immunity will last you for life. So like I should have chickenpox immunity for life. And some of these other immunity, like for other diseases like polio, is for life, but then some others won't be for life. And so you have to get booster, vaccines to remind your immune system how to combat that disease. And so getting a vaccine gives you active immunity because your immune system still has to learn how to defeat the virus. So one of the things that you guys pointed out is that for these COVID vaccines, you need 2 shots. The first one, basically, and we're going to look at how COVID vaccines work, is going to trigger the first immune response. The second booster shot is going to basically reinforce, the immune system, what to look for and how to combat that. So a lot of people after the first dose, they'll have like 50 to 60% protection against COVID. It's not until the second dose that they have that 94 to 96% protection. So some people may have a false sense of security after the first dose. Oh, well, I'm vaccinated. Like, I don't need to wear a face mask anymore, or like I can go to this huge gathering. But you're still at risk of acquiring it. And even if you get your second dose, like it's not at 100%. So I think it's like 95 to 96. So while you're protected, or if you get COVID, it'll be a milder form, like there's still a risk. So it's still encouraged that people that get vaccinated still continue to wash their hands and take precautions. And then some people have caught COVID after the first infection, or after the first vaccine, even after the second one. I've been reading a lot about people that still catch COVID, but it could be more mild, right? The goal here is to not end up on the ventilator, to not end up hospitalized. And so the vaccine can help you with that because you already have that immunity. So that's active immunity. And the goal of vaccines they're like a drill for your immune system. And so if you train your immune system on how to recognize a virus or a bacteria and how to combat it and mount a response and create these memory cells, when you actually come into contact with the virus, you'll eliminate it like that, or you won't let it into the cells. It's like you build a shield around yourself, without actually getting the vaccine or without getting the sickness at full force. So let's explore how the COVID vaccine works and how mRNA vaccines work, and if you could catch COVID from this particular infection or the vaccine. I do want to also look at the meningitis vaccine because a lot of you are going to be getting vaccinated for meningitis here in the next couple months to a year because a lot of universities require that their students have the meningitis vaccine. And so that's probably the one that you're more likely to get sooner rather than later. In terms of your risks for COVID complications, they're pretty minimal for young people. I have seen that as more people get infected, you start to hear more cases of children dying from complications of COVID. And also sometimes you'll hear once in a while that a teen or a young person will die from complications of COVID. And so we'll look at why here in a sec. So, but for the most part, you guys are at low risk. So you're at the very bottom of the list for getting vaccinated for COVID. So people have been pretty much prioritized for who's going to get the COVID vaccine based on their risk. So obviously, if you're an ambulance driver, if you're in the hospital and you're in like everyday contact with people that are sick of COVID, then yes, we want to protect those people first. People that are in the front lines, people that work in public settings. You want to protect those people that are constantly coming into contact with others and that are high risk. So if you're like 65 years or older, like you're more risk of getting seriously ill. So let's protect those people. So you guys are at the very bottom of the list. So chances are you'll probably end up with the meningitis vaccine before you end up with the COVID vaccine. But let's explore how the vaccine works. And I gave you all the link here on your Google Classroom account, so you can look off of mine, but I also gave it to y'all if you want to study it further. But essentially, this is how COVID infects the cells. I know that we kind of briefly looked at it last time. So the virus that causes COVID is a SARS virus, and it's like the type of virus that it is more generally is a coronavirus because it has these little spikes on the outside that looks like this little, I guess the little spikes on a crown. So corona in Spanish. And so the virus uses those little spikes to get into the cell. Think of them like the key. And so your lung cells and some cells of your digestive system have the right lock that fits the protein, this little spike protein. And so that doorway is called the ACE2 receptor. And so once your cells let that virus in, because hey, they've got the key, so why not, right? According to your cells, they let in the virus. Then once the virus is inside your cells in the lung and digestive system will start to read the instructions and make viruses. Essentially, your viruses use your proteins, they use all of your raw materials to make DNA and RNA, and they make the virus out of that. And then after a couple of days, you'll be pumping out so many viruses and so many of your cells will have died in the process that you'll start to notice symptoms. So 2 to 5 days on average, people will start to feel symptoms. Then the immune system takes a while to like figure out that they've been invaded. What's going to happen is once the immune system is going to detect this. And just to give you a little bit of background, some people's immune systems are going to catch this right off the bat and you won't even know that you were sick with COVID. Like you will be an asymptomatic person. Some people's immune system handle it very well and maybe they have mild symptoms. Some people get very severe symptoms. And we'll look at why some people may have really severe symptoms and it has to do with their immune system. But anyways, once enough of the virus is pumping around in your body and you have enough cellular damage, the white blood cells are going to figure out that there's something awry. And so you'll have macrophages or specialized types of cells. So just to give you an example, I don't know where I left my hair clip. Here it is. Okay. So let's say that this book is the virus and my hair clip is the spike protein. So I'm a white blood cell. I'm going to engulf it. I'm going to get rid of it and destroy it. But I'm going to take a piece of the virus and use it to show the other white blood cells of the body, because there are different types of immune cells, but I'm going to show it off and kind of show the body, hey guys, whenever you see this, this is what we're going to look for. This is the enemy. So anytime you see this protein, attack. So then what's going to happen is you're going to have separate responses. So one set of cells, your B cells, are going to produce these antibodies here in blue, and they're going to coat the virus with it and mark it for destruction. And these will last for months or years. So anytime the virus actually gets into your body again, they're going to coat it right away and destroy it before it even infects your cells. Another response, your T helper cells or your natural killer cells are going to kill your cells that are infected. So if you have some lung cells that are currently trying to pump out virus, your T helper cells are going to kill those. So these kill your cells your T helper cells, and the B cells produce the antibodies. What can happen with some people, and this is why you hear of cases where you have healthy people that were young, had no underlying conditions, and they died of COVID complications. The reason that that happens is because their immune system is overreacting. And so imagine like your lung cells are dying from the virus. So the virus is killing them as they're escaping, like up here. But then on top of that, your immune system is killing your lung cells because they're also trying to kill the other cells that are infected. And so sometimes people have a very, very, very strong immune response, and those cells start to go real like intense. Like we're killing all these lung cells that are infected, and we're going hard. And then we're also going to kill the red blood cells that look like that blood type. I remember I told you they have the spike. Let's kill those cells too, and let's form clots. And so that can be too much for a weakened body already. So not only is the virus hurting you, but your own immune system is hurting you. This is known as a cytokine storm. And that's where you have those very serious complications of people having strokes, of people ending up on ventilators with serious lung damage, because not just the virus, it's not just the virus now that's ganging up on them, it's their own immune system. So you want an immune system that's going to regulate itself. You don't want it to go out of control, because then it'll actually work against you. So after the cells of your immune system work together to control the infection, you will have memory cells against the virus. So next time you come into contact with COVID, you're not going to get sick from it because your immune system right away is going to deactivate it and destroy it without ever feeling symptoms. And so this can take up to 7 days or more. You can develop those antibodies by actually getting sick from the infection. It could be any infection, but by getting sick from COVID, like you get sick from COVID, you feel awful, but then you recover, or you feel have real mild symptoms, but then you recover. Or you can go through this because of a vaccine. A vaccine will train your immune system without actually getting COVID. So let's take a look at that. And so with immunity, it can last a month, it could last years, or it could last for a lifetime, because COVID is new. Okay, it's like been around for COVID-19. So at the end of November, they found the first cases in China. So a little over a year. Like we don't know, for people that have gotten better, we don't know how long their antibodies will last. Like we just don't know if it's going to be like, we're only like a year and some in. Some people can get COVID more than once because their immune system, their antibodies wore out after a while. So let's look at how the RNA vaccine works. Okay. So the mRNA vaccine works by taking the instructions from the virus on how to just make the spike. So you don't make the whole virus because you don't get those instructions. You just get instructions on how to make the spike. Think of it like if I have a big book, 1,000 pages long, and I just rip one page out of the book and give you that page. Well, you're not going to know the context of the book. You're not even going to like, what can you get from that? Like very limited information. You certainly can't rewrite the book from one page. So that's pretty much the logic behind this vaccine, is you only get the page of instructions on how to make the spike protein. So you cannot make a whole COVID virus with just those instructions. There's no way. So then what happens is they take these instructions and they encapsulate it in like this lipid, like this little fat bubble. And then they inject that. And that bubble, by the way, the little fat bubble, is super sensitive to temperature. So it has to be kept at really, really cold refrigeration. I think it's below freezing to keep it stable. If it gets too warm, then it's going to become unstable and it's not going to be effective. So this is one of the reasons that it's becoming a challenge to get these vaccines distributed fast enough, because a lot of clinics or facilities don't have the refrigeration for that type of vaccine. But anyways, so they inject this little fat bubble into your body, and then it gets into the cell, and it doesn't interact with your DNA. It doesn't go into the nucleus. It doesn't change anything about you. All the cell does is it receives those instructions, and then the ribosomes read the instructions and make the proteins. That's what they're just going to make. So here you go. We never change DNA. We don't do any of that. We don't mess with the DNA. It's just instructions. The ribosomes read it, make the proteins. So then your cells pump out the proteins, right? Just the little spikes, And your immune system's like, well, what the heck is this? Like, what is that? So then you have an immune response. So they get rid of it. They present it. You make the antibodies. Okay, we're going to look for that spike. Think of this like a drill. So you know how like when we're at school, we have fire drills and we have active shooter drills, and we practice so that if we ever do have a fire, we know where to go if there's ever an active shooter, which I hope has never, ever happened. But we kind of we know what to do to keep hopefully stay safe. It's the same thing. This is a drill for your body. So sometimes as we're going through this drill or the immune system is practicing, you're going to have an immune response, right? That's the whole goal, is you want to make these cells. So you may have an elevated body temperature. You may get a low-grade fever because your body is increasing its metabolism as it's making these antibodies and white blood cells. It's just part of the immune response is your temperature will increase. One of the reasons to deactivate proteins. But it's increasing its metabolic activity, right? It's very busy now, making all these antibodies and white blood cells. So your temperature is going to go up. So some people may also, during the first dose, they have real mild side effects. So low-grade fever. A lot of people most people say that they have pain in their arm from the infection. I know two people who have gotten vaccinated. One got the Moderna vaccine and one got the Pfizer vaccine, and both talked about how much their arm hurt and they couldn't even lift it. But when you get the second vaccine, when you get that booster, your immune system's already seen the spike protein, so the reaction's more intense. And so usually after the second dose, you're reinforcing the immune response. And so that's when people get more serious side effects. Like that's when they get the higher fever. Some people get really intense chills. I remember reading, and this scared me, but I remember reading that this one participant in the vaccine trial said that they were shaking so bad after the second vaccine that their tooth chipped just from like the chattering of the teeth, or that just they felt awful for a couple of hours. They took Tylenol and that managed it, but it was pretty rough there for like a couple of hours while the immune system was mounting that second response. Some people can get headaches from it. I know another individual that got the vaccine and they kind of like brain fog after the second dose. And then after about a day, they feel better and they should have that protection. So of course, all these things can sound very scary, especially like if you're going through it. Am I going to be one of those people that gets allergic reaction? Is this normal? But you can't get COVID from the vaccine because it's only coding for the protein. Now, you guys have probably heard of the mutations. So the virus is mutating. It's getting more effective at infecting people. And sometimes when a virus mutates, the vaccine won't work anymore because the body was looking for this protein. And now, let's say it changed it to this protein. So all of that practice for what? Like we changed it up on them. So fortunately, these new mutant strains that are coming out that are, because the virus is getting more efficient, like it's getting better as it infects more people, it's fine-tuning itself. So this there's, depending on where they find the mutation, they call it that variant. So there's a UK variant in the UK or Britain. Then there's a South African variant. They found that one in South Africa. And so these new mutations of the COVID virus are more infectious, like they're more contagious. So COVID, on average, one person will infect 2 people. So these may infect larger numbers of people, like it's easier to catch. But fortunately, the mutations have not changed the spike. As long as the spike stays the same, as long as it continues to use that key, then the vaccine will continue to work. But if the virus mutates and it changes that spike to something else, another way to get into the cell, then we have to start from scratch to make a vaccine for that. So hopefully that doesn't, because really one of I think our best chances of being able to return back to normal is to, rein this pandemic in by giving them immunity to COVID. And there are 2 ways to do that. Either get everybody sick from COVID and now they have immunity, but complications or death, or get people vaccinated and hopefully they'll be protected that way. And very few will get side effects and hopefully nobody will pass from it. But people just have to make that choice for themselves. But it's something that COVID is not going to go away really ever. Like, I don't think like smallpox, it'll always be around. I think we just can control it. We can control how serious it gets and hopefully we'll come up with treatment options, but it'll be around for a long, 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 long time. Okay, so that's active immunity because the immune system had to go through all that work. I think I already showed you the vaccines. Let's talk about the meningitis vaccine because that's the one that you guys are more than likely going to be getting here pretty soon. So meningitis is recommended for all college students. It does infect with 3,000 people in the US and it kills about 300 annually. So you may think that, well, that's not a lot. But again, like one person too many from a preventable disease. And so one of the reasons that meningitis can spread very easily at the college level is because it is transmitted, I believe, through saliva. Saliva is one of the ways that you can transmit it. And so I'm looking for this. Okay. So meningitis targets the covering of the brain and spinal cord. The covering of your brain and spinal cord is called the meninges. So meningitis is an inflammation of the meninges caused by a bacteria or a virus. They could be from either. There's viral meningitis and there's bacterial meningitis. There's also fungal meningitis. That one's more rare though. So what happens if you catch this virus or bacteria, it causes an inflammation in the covering of your brain. And so what that can cause is, now that there's inflammation and swelling around the brain, you can go and you can start having seizures from that, even if you've never had seizures before, very intense headaches. You can get a stiff neck as the spinal cord will, the covering around it swells. You can't turn your neck, cause a lot of pain because of the inflammation. Very, very, very high fevers. We're talking 103, 104, and people die from it. They can end up very, very sick from meningitis, or even end up with brain damage. Some kids that have had meningitis as children or babies, they end up with brain damage from it. So it's one of those vaccines that's definitely, a lot of universities require it for people that are going into college, which will be here in like a couple months or next year. So with all vaccines, there will be side effects. And so I gave you guys from the CDC, the insert. So it goes on to talk about meningitis, but I want you to see the side effects. So with most vaccines, you're going to get side effects. Most of them are mild, but fevers are pretty typical because you're mounting an immune response. So that's going to increase your metabolic activity and your immune system is being primed. So it's pretty typical to develop a low-grade fever. A lot of people feel fatigued because a lot of energy is being invested into making white blood cells and antibodies. So you're going to get tired from them. You'll feel sleepy, lethargic, kind of loopy and out of it. Some people get headaches. That's pretty typical. You can see that here with the vaccine. And because you're being like injected with like stabilizers and preservatives and some chemicals, you'll have a reaction sometimes at the like swelling or pain at the site of infection or at the site of injection. But with all vaccines, COVID included, some people can have allergic reactions to whatever other chemicals are in the vaccine, because there are stabilizers in the vaccines to keep the vaccine from spoiling, and there are preservatives to keep them from growing mold, and there's all sorts of things in vaccines, not to mention like the bacterial parts or viral instructions. And so everybody's different, and some people may have an allergic reaction. So I know with the COVID vaccine, they recommend that if you've had allergic reactions to other vaccines in the past, that you not get this vaccine, because it's possible that you could also have a reaction to this one. And so an allergic reaction, basically your immune system is overreacting to something that should not be harmful. And so some people are allergic to certain types of foods, like the immune system will react against peanuts or eggs or shellfish. I know my brother, anytime he eats avocado, his tongue will swell and his throat starts to itch, so he can't have avocado. And that's because your body is producing histamines, which for the most part cause itchiness and runny nose, watery eyes, sneezing. In some cases, the reaction can be really severe, and you could have some pretty serious swelling of the body, because remember that your immune system reacts to some of these infections by sending a lot of blood and white blood cells to that area, and that causes swelling. And so if this happens in the airway, that can cause or like a whole body sort of reaction. You go into anaphylactic shock and you can't breathe because of all of the inflammation that's happening in the body, and it happens very quickly. And so for those individuals with very severe allergies, they have to carry an EpiPen that produces, it's a chemical that neutralizes the histamines that are causing these reactions. And so when somebody gets an allergy test, they'll prick them with each of those allergens. And if they have a reaction like the swelling and the redness, all the typical reactions of an immune response, that is an allergen for them. So this guy right here, usually they'll use the back. Sometimes they can use the forearm, I think. But you can see the swelling, some welts that are developing. Those are things that they're allergic to. So they're having an allergic reaction. And so with vaccines, somebody can also have an allergic reaction, with COVID vaccine included. And so that has already happened with some individuals that have gotten vaccinated. And so oftentimes, especially with all vaccines, but I know I've heard it with the COVID vaccine, they'll ask you to wait 15 minutes after they vaccinate you to stay on the lookout for those allergic reactions, because they'll happen in a short amount of time. And if you do develop an allergic reaction, like the itchiness, dizziness, maybe trouble breathing, they'll give you some sort of antihistamine. Like I know they're giving Benadryl. If it's really serious, and they'll take you to the hospital and observe you there. And then with any vaccine, there's a risk of death. You are introducing things into the body that you don't, I mean, if it's, you don't know how your body's going to react. Everybody's genetics are different. And so people have died from vaccines, or they've gotten seriously injured from a vaccine and the reactions to the vaccine. And so it's rare, but it can happen. And so that's something that as a parent or just as a person, it's very scary because you're taking your healthy little baby. There's nothing wrong with them. They're perfectly healthy, and you're injecting and they're pumping all of these vaccines. Like by the time you're 6, I think you have like 69 vaccines or something. It's in the PowerPoint. Or you're taking somebody that does not have COVID, like they're perfectly fine. They've avoided COVID all this time, and then they get vaccinated and they get a reaction. And so that's also a very scary thing. And so again, you just kind of have to consider, you have to weigh your pros and cons to develop a COVID infection and the side effects that could happen there, all the risks, or the slim very minimal chance that you could get very sick and die from a vaccine. And so usually when somebody gets seriously injured from a vaccine, there's like a compensation program where they'll look into it. And if the vaccine did cause the person's death, there's like some sort of financial, I think, help that the families get for whatever needs. I mean, because you just look, you know, it's terrible. I mean, you can't bring the person back, but I guess they'll try to rectify the situation somehow. But the more people that are getting tested, like if there's something that's triggering these responses or these allergies, you can fine tune the vaccine to remove that and eliminate that. And that's what the human trials essentially want to accomplish, right? But I don't know. Obviously, we're going to be finding out still a lot about the vaccine as people get vaccinated. Passive immunity, I think we talked about this last time. So passive immunity, you're immune, but not on your own accord. Like you didn't ever get sick or vaccinated. You got immunity from somebody else. So when a mom is pregnant, the baby gets all of her antibodies through the placenta. So if mom had chickenpox, baby's immune to chickenpox. If mom got vaccinated for measles, baby is immune to measles. If mom survived COVID infection, she's got antibodies while she was pregnant, baby gets the antibodies. And so babies, it's kind of Mother Nature's way of protecting these babies because their immune system is like pure. They've never seen any of these bacteria, viruses that are out there. And the womb is so safe for them. So when they're born, the mother's immunity will last them for like 6 months. And after 6 months, right, hopefully they're healthier, they're a little bit more robust. If they get an infection, they have better chances against it. So 6 months of immunity, it's passive because the mother gave it to them. If a mother breastfeeds, whatever the mom is immune to, baby's immune to also. So if that mom breastfeeds for 2 years, baby continues to get those antibodies that whole time. And so it's encouraged that moms breastfeed their babies to give them all those antibodies. And so there's actually research going into breast milk of women that have had COVID, and if their antibodies in the breast milk could help as a treatment for people. So it's legitimate science. I mean, there are antibodies there if she's had COVID or any other disease. And so that's passive. Another type of passive immunity, if you get plasma from somebody else, you're getting their antibodies. So if Billy had COVID 2 months ago and I'm in the hospital with COVID, they'll give me Billy's plasma so I can use his antibodies to fight the virus while I make my own. So while my immune system catches up, the virus is not replicating in me anymore because Billy's cells are helping me. And so that's passive because I'm using Billy's. So that is vaccines. We'll talk about HIV when we meet on Wednesday. Super interesting stuff. I love the immune system and diseases. But anyways, make sure you get that Padlet done tomorrow. I'll have an assignment for y'all, and I will see y'all later. Bye.
Bye. Have a good day.
You too. Thank you.
Bye, Miss. Have a good day.
Bye, Miss.
You too. Bye.
Bye-bye.
Bye.